So the objective of this session, long title, simplifying network deployments and so on, but basically I'm trying to make your life easier. That's the point of this entire technology, to make life easier so you can focus on fun stuff instead of boring stuff. Doesn't that sound nice? Yeah. Okay, so let's look at some numbers. Deployment, that is how to get stuff up and running, our devices and so on. The interesting thing is that usually, if you look at the total cost of ownership, how much money you're actually paying for this, you buy equipment from Cisco, usually expensive, or you could buy it cheaper from someone else. But then, regardless whom you buy the equipment from, you have to deploy it. And on the average, you're spending about 30% of your budget just to get things up and running. Usually, it takes about 30 days to get the device out there and get it to start earning you guys money. And it takes 2/3 of the things required is repetitive. You're doing the same thing again and again and again and again, and that's boring. So, what can we do to make this easier? Well, before I go there. Here's an interesting number, and this is something we talked to a number of service providers around the world, and try to estimate how much money they're actually spending on the deployment. The first number here is pre-configuration, because usually, when you get a device from Cisco or someone else, then it is empty. Doesn't do anything, and you have to put your own configuration onto it, such that it will work in the customer environment. On the average, you're spending about $700. Sounds a lot, but if you begin to think about all the work needed, it actually adds up. Then you need to have it shipped to the right location and so on and so on. But then, if something goes wrong, and on the average, 1 device out of 10 will go wrong in some way. Meaning, you have pre-configured it, you have sent it to the right location, it is being installed, and so on and so on, but it just doesn't work. So you have to send someone out there to do things. And that is often a lot more expensive, because that is delaying things from happening and so on. So total about $1,500. What I'm saying is that if you do things properly, you can probably reduce this down to $300, saving on the average $1,200 on the deployment. And then, of course, what I'm trying to say to you, if you have a clever network device, which is extremely cheap to put in production, versus another device which is maybe a little bit less expensive, but requires to pay additional $1,000 to get up and running, well, then you see the picture. I'm trying to save you guys money and save you time. So, what is this all about? Has anyone heard about autonomic networking in here? Okay, 1 person, that's good. 2, cool. Actually, this is an idea which came from IBM back in 2001. And what they were talking about is about autonomic networks which are self-managing. Self-managing in the way that they configure themselves, they protect themselves, they optimize themselves, and do self-healing. For those who have been around for a little bit while, if I say the word Skynet, then you probably... Well, we're not going in that direction. But think about what's happening these days. The self-driving car. That is like Google car. You just go into it, and you punch in, I want to go to work, and it just drives itself. And then you sit there and read the newspaper. That's nice, because the car knows how to drive itself. It understands traffic. It understands the traffic rules. It can adjust to its own environment. It will try to protect itself and the person in the car, and so on and so on. Basically, it is doing all those things. The same thing with drones. Amazon has talked about if you buy something from Amazon, they will actually send the packets using a drone to your home and drop it in the backyard. Actually, I think they have actually begun doing it in Finland recently. Some of these small islands which are far away, you need to send on a boat, they just send a drone with the packets and drop it down there. Just be careful that you don't leave your dog in the backyard when the drone comes. Some technical aspects about chopping people's heads off and so on, but okay. But you understand the issue. You have to have those things in place. We already have them in many places in the industry. You have our smartphones, the iPhone and the Android phones, which are extremely clever, and they are extremely complex, but they hide all the complexity beneath the user interface. You don't have to care how the phone works. Also, another example, static routing. Static routing was something we did long time ago, saying, I want this traffic to go to the right, and I want this traffic to go to the left. And this didn't really scale. So someone came up with a routing protocol. A routing protocol is actually an autonomic function which talks to its neighbors. It receives information directly from the neighbor or accumulated information from the neighbor. And then it will actually, on its own, decide to send packets in that direction. It's a self-thinking function for a very limited role, but we trust it. We might play around with the parameters and stuff, but we are actually allowing that piece of software to take its own decision, and we're perfectly fine with it. So the question is, why can't we do the same thing for security? What about quality of service? What about all the other stuff we're doing on a regular basis? And that is basically what I'm trying to say. We want to come up with the autonomic network, which in a way is actually implementing what we call the Cisco validated designs, meaning instead of just being a stupid box doing nothing until you configure it, then actually to provide basic functionality, become available, become manageable, and in such a way that it can actually deploy your services without having to do all the boring stuff. I think that makes sense, doesn't it? But then the question is, can we do it properly? Of course. And you probably know all those nice Cisco validated designs. We come out with a new feature, and we give you a 1,000-page document and say, go off, have fun. Well, meaning we leave everything to you guys. You have to do everything. We would like to make this be if you want to implement quality of service or MPLS or something, you turn it on, and it will work according to the validated designs, but then you can tune it according to how you want. Focus on what's important for you, the services and how you use the network, not how it works. Like the iPhone, you just want to call someone or surf the internet, it just works. Okay, so a lot of interesting things. You will see a number of these at the bottom. And this comes back to what I've been saying, we are standardizing this, we have open source for this, and you'll have all the links to it at the end of the presentation. So this is not just hype, this actually is real. At least the first parts of it. So, we began thinking about this about 4 years ago. And actually, 2 sales guys, Cisco sales guys, were thinking, security is a pain. It is so difficult to implement properly, and they're always doing it again and again. I thought, can't we do this in some other way? So we came up with an idea. We built a prototype. The prototype worked perfectly. The idea was wrong, by the way, but anyway, we understood what was wrong and built the next idea. And in order to, because we want to solve security, we haven't solved it yet, but in order to do that, we actually solved another problem, which is the deployment problem. And that's what I will be talking about, So basically, what I'm talking about today is a coincidence. We just had to do it, and suddenly, whoops, we have a nice solution for something. But the real stuff, the really cool stuff, will come in a few years. But this you can use now. So, as I said before, usually, this is what you do. You need to buy the box. You need to pre-stage it. You have to make it usable for your customers. It has to be installed in some way. And then you have to activate the services, you have to customize it, and then maybe something goes wrong again. And we are removing both of these things, totally. So you can focus on just buy the box, have Cisco or whoever you buy the box from send it directly to the customer, and it will just work. Okay, so let's go a little bit into the technology behind all of this, which is interesting. So, first of all, for Autonomic to work, you need 1 special device and you need 3 lines, CLI lines. That's it. 3. Nothing more. And the rest will happen automatically. Because this device, the registrar, is a device who decides which devices are part of my network. And that is extremely important because everything is based on trust. And you need to know whom to trust. So, if this new device pops up, then the only thing we need, basically, you don't need a config or anything, you need a UDI, a unique device identifier, or what we would rather prefer is a secure UDI. Basically, the product number and the serial number of the device. Because you usually know which devices you own. And if you can match the serial numbers against a whitelist, which you have here, then you can decide, this device will become part of my network, yes or no. Okay? So, but before you do all of that, we need to do, as you know, with layer 2 and VLANs and stuff, sometimes we have to do discovery. So we do that. We actually, the new guy, which has no configuration, he doesn't know about which VLAN he should be using. So we fix that. We do probing and all of that stuff works. I have more details later on if you want to go into exactly how it works. But okay, so let's assume we find each other. So he tells me, this is my product number and serial number. The registrar will then take a look at this and decide, okay, it's a ISR 4451 with serial number 12345. That's sort of okay, because now I'm just talking about the UDI, which is in clear text, and yes, it can be spoofed. Preferably, I would be using the SUDI, which is actually burnt onto the motherboard of the device itself. I'll talk about SUDIs a little bit more. But there is a way to absolutely be sure that this is Michael. No question about it. If it's Michael, we will actually provide him with a domain certificate. Now I use the word certificates, and usually people start screaming and running out of the room when they heard about certificates, because those are pain, usually. But the protocols we implemented for this, because nothing existed, they solve all of that. You don't have to think about the certificates. It just gets deployed, it works, it has failover, rollover, and all those things. You just end up with a certificate on the device which says, this device now belongs to Cisco, Juniper, or whatever customer is using this. So it's yours, which means we trust it. And that's the cornerstone of absolutely everything. The trust. We trust him. We have decided that he is now part of our network, and we will start talking to him, and we will start to do stuff. If he's not part of my network, then he's out. So that's very binary. Either in the network or not part of the network. But okay, so let's assume he's part of the network. Wouldn't it be nice to be able to actually talk to him? That is actually to provide him with information, or actually put a configuration or service in place. That would be nice. But usually you require IP addresses on devices, but not in this case. We are actually able to establish a separate VRF, a management network, establish the tunnels, enable encryption, and be able to talk to this guy with no configuration. And I'll be saying not a lot, because there's no configuration on this guy. He's able to communicate with the rest of the world, and you can talk to him and configure him and so on with no configuration. And actually, when you go in and type in show autonomic device, you will see the UDI, which I mentioned previously, some kind of serial number, internal, just used for the registrar, and you will see the certificate, and then you'll see this, which are the domain local IPv6 addresses. You'll see it by using the FD, which you have allocated to this device and will follow that specific device for the rest of its lifetime. You will always be able to talk to him if you know this. So, let me ask you a question. How can I talk to a new device with no configuration whatsoever using IP? Magic is one word. There's a hint here. Look at this IP address here. What happens if you enable an interface on a device which understands IPv6? IPv6 link locals. Correct. Because IPv6 link locals are basically IP addresses which are automatically generated on that interface when it becomes enabled, and is guaranteed to be unique for that link. But in the end, it's just an IP address. It's an IPv6 address which looks like a little bit funny, but it works. We do it on both sides of the link, and we had to change some code and do some creative engineering, but we actually managed to create a tunnel. Theory tunnel in this case, which the source address is the IPv6 link local on one end, and the destination is the IPv6 link local on the other end. And then we encrypt it. And why do we encrypt it? Because we want things to be secure. We don't want people to see our configuration, or change it, or do anything with it. We want to have secure communication. And actually, I mentioned we have a routing protocol as well. Why do we need that? Because sometimes you have networks with more than 2 devices. Let's hope you have more than 2 devices. Because when Steve shows up, we do exactly the same thing. So Michael sees Steve sees Michael, and I say, hey, I'm the new guy. Can I join? So Michael will say, cool, I'll help you. But Michael will do the channel discovery, the collective serial numbers and stuff. But Michael will tell the registrar, Steve just showed up. He's now connected to my interface. Should he be allowed to join our network? Yes or no? If the registrar says, OK, and I'll blank this, then we will actually provide him with a domain certificate, and he'll become a member of our network. And if we take this even one step further, then you see Steve is here. We establish the control plane to him, so we'll be able to talk to him. And this is the reason why I need a routing protocol, because we're building a mesh network in a way, hop by hop on every link. That means we need routing. So we enable a routing protocol. Actually, we use a routing protocol called Ripple, RPL, which is used in Internet of Things. It runs on light bulbs and stuff. Almost no CPU, no memory, doesn't require anything almost, but it's perfectly fine for a management network, because you don't care if it takes 1 or 2 seconds for failover stuff. And if we would use OSPF or RSS or something else, we would be taking away CPU from you guys, because this happens automatically. You don't see it. If you go in and do show run, it's empty, because we just make this happen. Yes, we will use some CPU, but we are aiming to, we aimed initially for 5%, but we're currently at 3%. You do not take more than 3 to 5% off your CPU to make this happen. And now, when all the other guys show up, we just do the same thing. And it just works. Again, I can take all those devices, I can plug them together. The only technical skills the guy setting up the network needs, he needs to know the difference between a power cable and an Ethernet cable. That's it. And then everything will pop up, and you'll be able to talk to every device in a secure way and implement the services you want. Sounds interesting? OK, cool. So what can we do with this? So let's assume things are up and running. You've deployed your services, life is good, and OK, probably you will have a little bit more complex network than this. But let's say he shows up. He was doing something on your network, like he was changing the user authentication and typed in the wrong parameter for login, or he suddenly did write erase reload on the wrong device, or something interesting. I'm not going to ask the question, because I was going to ask, who has never done a mistake on a device like this? Well, I think we've all done it. At one point or another, we do oops. And oops, which usually requires you go out and get your console cable, plug it in, and fix things. The problem is some customers have devices on top of mountains. Some customers have devices which are actually down in the sea, or some crazy locations where actually will need a helicopter or a submarine to go in and plug in the console cable. That is not fun. One of our customers said, if I would have to do this, it will cost me $1 million an hour to fix it. Then we're talking about serious money. So they like the idea. Because the idea is, even if something goes wrong, the device is still reachable, you can still talk to it, I can connect to it using a PC, using SSH, I just log onto the device, and I connect to it, and I fix it. The only exception is, if you cut the cable itself, we can't solve that. We can't stitch cables together remotely. But as long as the cable is plugged in, we should be okay. So we fix things. But another question for you guys. I said I would use SSH to connect to this device. And let's assume we did write erase reload on it. So it has no, again, it is blank, has nothing. How can I log onto a device using SSH if I have no user configuration in this one? I have no AAA configuration. It has nothing. How can I use SSH? Say again? Certificate is one way, and that's actually a good problem. The only problem is that SSH with domain certificates hasn't been implemented yet in the industry. It doesn't exist, but you're on the right track. Say again? But yeah, that is also another way. Actually, you're coming with really clever ideas, so keep talking. But let's assume I want to type in Cisco and Cisco 123 to log in, because everyone uses Cisco 1. Well, no, we would not be using a predefined user on this. If we would do it, then we would get fired. We know that. You do not have a secret username and password on a device, because that is never a secret. We do not have an empty allowing anyone to log on, because again, that's extremely risky. So how do we learn this? And I'll just jump to the next slide, service discovery. So instead of having to configure services, you discover them. You learn about them. Meaning that in this case, if we're talking about AAA, then instead of configuring the AAA server, we just have the AAA server itself or someone else on its behalf announce it. Just tell everyone, if you need AAA, then here's the service. And actually, it looks like this. So every device which joins the control plane, becomes part of the network, will automatically learn about all those things, like AAA. Just go to 2000:1. If you need TFTP, here's the address, here's DNS, here's NTP, so on and so on. We just announce everything, and you learn it. Which means that this guy, when I was connecting to him, he would have learned about the AAA service, and would then use that to validate the username and password when I type in when I connect to it. Because you have to be in control of who is allowed to talk to your boxes and what kind of privileges they have. And this solves the chicken and egg problem. I don't have to configure things, you learn about them. Okay, this is interesting. Usually what you would want to, there's only one problem here. As was pointed out earlier, we are using IPv6 link locals. What happens if this cloud here would actually be a layer 3 cloud? Nothing. Meaning, actually, nothing will happen because IPv6 link locals do not work across layer 3. They should actually, most equipment will drop packets with linked local addresses if they begin to try to go across layer 3 hops and so on. So this will not work across layer 3. So, but it could be a virtual layer 2. GRE tunnels will work, pseudo wires will work, basically everything which emulates a layer 2. But that was kind of a hindrance to us, so we actually decided to do a clever thing in Cisco. We decided to talk to someone else in Cisco. Because usually, in Cisco, when we do something, we do not do it once, we usually do it about 5 times. Okay, I'm trying to be a little bit sarcastic, but that's how you customers usually see it. You see 2 or 3 different solutions, all attempting to do the same thing. None of them is quite good enough, and they never ever talk together. Sounds familiar? Okay. But in this case, we decided to talk to each other. So we talked to another team in Cisco, the PnP guys, Network Plug and Play, which actually solved the layer 3 problem. We've solved the layer 2 problem and the control plane stuff. They have solved the layer 3, so we decided, let's work together, see what we can do. So, what have they done? They have, it's sort of the same underlying concept, but in the way that they have something they call the PnP agent. This is already being used in enterprise, but this also applies to service provider because now they have moved the code into the service provider platforms. So you have the agent. Basically, it sits there and does stuff. You have a server, something which you talk to, which could be a standalone. Actually, it's a Python code which is running standalone. Or it's part of the APGM for enterprise, it's part of TLF, it's part of Prime. Basically, it's just some server code running on a Linux platform somewhere. And this one is responsible for storing the configuration and images and stuff, things you want to do with a new device. So the new device wakes up and will attempt to talk to this PnP server and saying, hey, I'm here. And they also use the UTI and stuff. But they do it across layer 3. If for some reason layer 3 doesn't work, you need to put some parameters onto the device before you can enable the network. Then they came up with a solution on an iPhone. So you have an iPhone with a serial cable. The iPhone talks to the server. You just take a picture of the box itself with the serial number. It will then take that picture, scan the serial number, talk to the server over here on the right-hand side, and then the configuration will be put to the iPhone through the serial cable into the device. It works. Kind of easy. For the guy out in the field, the only thing he has to do, he has to be able to use an iPhone and take pictures, which most people can do. But okay, that's only if the rest of the stuff doesn't work. So, what do? They work with us for layer 2, but here's what: if Autonomic is not able to do its stuff, then they go into layer 3, which means using things like DHCP. Because that means the new device, let's assume it gets a network connectivity, and there is someone giving him an IP. That means in many cases you can give him some kind of DHCP option. Say, here's the IP address of the PnP server, go and talk to him. If that doesn't work, then there might be that you need to use DNS instead. DNS means you pre-populate the name pnpserver.yourdomain.com, and then we'll try to go to that. If for some reason you have a customer in China or some very far distant location where you have no control of anything, but they get internet, then we can actually use the cloud. Because the device itself, it knows it's a Cisco device. Well, it is produced by Cisco, it knows it's Cisco, and then it will actually call home to Cisco and say, hey, who owns me? Is it Cisco? Is it Telecom Italia? Is it Orange or whomever? And then Cisco will tell that box, hey, you're owned by Telecom Italia, talk to them, and here's the IP address. And then it will connect to them, and then they will pick it up and do whatever they want. Everything automated. And set the installer up. So if we combine these things together, then here we have the headquarters or the main location or whatever. Then you have the AN registrar, you have the PnP server. These devices, they are directly connected. They will discover each other. The control plane will come up. You can manage them, do whatever you want. This site down here is remote, but it has a layer 2 connection. Physical, virtual, don't care. But this one is AN enabled. It's part of the domain. This one pops up. They will talk to each other, and they will become part of the domain. He will establish the control plane, and then this guy will then continue and bootstrap the next guy. It just spreads out. Here we have a layer 3 connection. So let's assume that this layer 3 network is something you control in some way. Meaning you can play with DHCP parameters or DNS or something. Then the same thing what will happen is that AN on this device, these will not be able to communicate because it's no layer 2 adjacency. But he will be able to use DHCP. He will get an IP address. And then, as part of the IP address, he will be told the location of this guy. So basically, he will then connect to him, because he has an IP address. He connects, the agent, PnP agent, talks to the main server and will then be able to say, hey, I'm here. Please help me. And the answer could be, you'll get a small configuration which builds a GRE tunnel back to this guy, or whatever you want. Because then you establish the GRE tunnel. Now we have a layer 2 adjacency, and then AN pops up, bootstraps this one, and then bootstraps the other guy. So this is actually sort of logical. This box in China wakes up, no one tells it anything, but it will get an IP address from the internet. So it will call home, it will actually call Cisco, say, I'm the new guy in China, who owns me? He will tell you, Telecom Italia, here's the address. You then connect over here. Again, the same thing happens. Push out a small configuration, which in this case would probably a DMVPN or IVAN configuration with security and stuff, because we don't want the Chinese to see what's happening. Establish the tunnel, which again will give you a virtual layer 2 adjacency. AN will come up, and you're home free. Basically, using those two technologies together, we can solve the layer 2 and layer 3 problem, be able to push an image, push a configuration or an image, and give you secure connectivity to every box, regardless of what happens. So if Homer shows up in China and there's a write to radius on this box, what happens? Well, the box reloads, but goes through the exact same procedure again, and will be up and running in 5 minutes. So I think this is pretty cool. And what amazed me the most is that when I took those two technologies and tested them together, they just worked. So I began to think, something must be wrong. But OK, I checked again, and they actually work. OK. So let's change. Any questions at this point of time? Or? So let's change gears and talk a little bit about security. The reason for talking about security, I'll actually be pointing you back towards autonomic. But you have probably seen in the recent news interesting articles like this, Sinful. Articles saying that a lot of devices have been attacked and owned and taken over by hackers and used to spy on or steal information from networks worldwide. What, of course, they don't explain is that this is actually not a vulnerability in the product. Someone had administrator access to the devices. If you have physical access or admin access to the devices, it doesn't matter if it says Cisco on the logo or Juniper, whatever, you own that box. So it has nothing to do with Cisco, but people don't explain those things when they put those articles out. ROM1, again, same thing. Someone who's replacing the ROM, the boot ROM on the device. And then you have this one, which is a little bit older on, which is our friends in NSA. Do you know the story behind this picture? And actually, I think this is a good picture, because it shows you, here's a Cisco device, which was on its way from Cisco manufacturing to a customer somewhere. These guys from NSA, they actually hijacked the box on its way, took it into some location somewhere, turned the box upside down, removed the sticky tape, and changed the device itself. And then put it back into the box, put the sticky tape back on, and sent it to the customer. So they're modifying the device on its way to the customer. So the thing number one, when you open a box from Cisco or anyone, look at the tape underneath the box, if someone has messed with it. That's the first thing, because you never check that. You check the things on top of the box. Number two, I'm going to tell you how to solve that in a few slides. Even if when NSA is coming and doing bad things. So, what kind of attacks are we talking about? We are talking about, the first one is basically, you're modifying the code on the device itself. Could be the operating system, could be the ROM on, something running on the device, which means you gain control of the device itself. That's kind of obvious. Here's another one, which is a little bit more nasty, meaning you don't modify the software on the device, but you install a software on the device which has a vulnerability. Because if, for some reason, we would have a bug in our software, you're supposed to laugh now, because everyone has bugs in their software, and that would mean someone could take an older image and put it onto the device, meaning not changing it, but he knows there's a vulnerability in iOS 13. So you're running 15, but he installs 13. Because then he knows he can then gain control of that device until he discovers running old code and then so on and so on. So that could be an attack vector. Here's NSA modifying the device itself. Number 3. And that's rather nasty because I've heard about attacks where you actually can, if you take out one of the Ethernet modules in our products, you could they have their own CPU and run their own operating system and stuff. There exists code to run SSH server on a network interface card. So you can SSH to the card itself. And because the card, in many cases, have DMA access to the entire memory of the device, you can basically see everything. That's kind of nasty. So if someone is modifying the hardware in the box, that could really cause problems. And then everything which I talked about earlier about joining domains, becoming a trusted device. What happens if someone hijacks the device, meaning it joins first hackers.com, gets modified, and then released back to you? So we need to change things, and this is what stuff which we're working on now. This is the overarching concept which is called secure by default. It basically means using these concepts of self-protection and so on, the network should protect itself because it has the capabilities to do it. So how do we do it? We need something as we call a secure network device. The first thing is we need to have secure hardware. That's the key to this. We need hardware which we can trust. Because if we have hardware which we can trust, that means we can then actually use it to validate the software running on it. If we can validate the software running on the device, that means we can actually do cool things like Autonomic, give domain certificates to it, so we can trust the devices as part of our network. And then if we add something which we call attestation, that means we can actually analyze the device and use that as a factor to decide, should you be allowed to join our network, yes or no? Things like, are you running the proper software? Are you running the proper hardware? Has someone modified the Ethernet modules? Is there a USB stick plugged into your device? And so on and so on. All of these things should be factors deciding if you can trust the device or not. So, let's talk about secure hardware. This is a rather interesting chip. It's called the SUDI. We use it to store the SUDI, but actually the name of it is ACT2 or TAM. It has different names. It's a chip on the motherboard of the device, which you cannot modify or do anything with. If you touch it, it dies. If you try to open it, it dies. If you try to modify it, it dies. You cannot modify it. The interesting thing is that we can actually use it to store things, and we can use it to sign things. So what we do is that we insert the serial number of the device itself onto that chip during manufacturing. And then that is signed. And we put the public key of Cisco into this chip as well. So number one, we know that the device itself is actually from Cisco. We know that it has serial number 12345, and the device now has the capability of doing things like validating the software itself. Because if we sign the software, when we produce the software, we sign it with Cisco. This is produced by Cisco. Here's the hash signed, da, 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 da. The chip can now validate that this is proper Cisco software, which is kind of cool. Because we're tying it back to hardware which cannot be changed. Actually, the reason why we did this originally is that we had a big customer in the US which was complaining that the Cisco boxes, they were always dying when the CPU went above 50% or something, which was not good. If you go beyond 50%, the boxes continue to work. We began looking at those boxes. We didn't find anything. But when we actually began to take a look at the physical boxes, Then we saw they had the Cisco logo on front, but it was not Cisco hardware. It was someone in China had cloned our hardware, copied our hardware, and put some crappy stuff into it, and sold it as legitimate Cisco boxes. That happened a few years back. That's the reason why I put the chip in place. Actually, this is now still happening in the way that if you're buying a 3800 routers, you have 3825 or 3925 and so on. People are taking less expensive devices, modifying them on hardware level such that they look like a more expensive device. They don't, the chip is running at the wrong frequency, the memory is according to the specs and so on, so it will crash and die sometime. But people are selling devices which look like Cisco, but are modified or hacked in some way. So that's happening today. So, but with this chip, we now know that this is a Cisco device, which means when you trust it, when you boot, first the chip will check the bootloader itself. If the bootloader is okay, then the bootloader can then launch the OS. If the OS is okay, then you can continue and do other stuff. Sort of logical. So, if we have all this in place, that means we can trust our devices. We can build a secure network, which means we can actually start talking to each other. And if we can talk to each other, we can protect the network itself automatically. If we can do that, then we can put all kinds of automated security and stuff together. This is the security story we thought about 3 years back. We're not quite there yet, but we're on our way. The first thing is that we are integrating this boot stuff with autonomic networking. Because here are the 4 attacks. The new device shows up. So the neighbor, he's trusted, he will have policies and so on. So he says, hey, I'm here and so on. He will first do all the validations and validate its own status. This is what we call assigned health information packets. This is how I'm feeling today. So when he shows up, he will send his own information, SUDI or whatever, or if he's already part of the domain. If for some reason a device goes offline and then comes back, you should check why. It could be that the power went. It could also be that someone has modified the device. So we do it all the time. We take the health information, send it to this guy who can then analyze it. Is the software okay? Is the right software version installed? Is the hardware according to specs? And so on and so on. All of this is signed by the chip, so you can trust it. Then we send back a policy decision saying, yes, we trust him, or no, we don't trust him. If we don't trust him, we put him in quarantine. Because it could be that this is just an old box which is running iOS 15. Now we're up to 17, whatever. And it's been on a shelf somewhere. It's just the backup box which is located somewhere, and then someone took it off a shelf and plugged it in. Yeah, we want to be able to upgrade it. We don't want to shut it totally out. So the interesting thing is we're taking autonomic networking and trusted boot, the technologies, combining them into something which actually one of my customers said, this is network admission control for network devices. It's giving you control of what's happening. And this actually solves all the 4 problems. So we've solved Sinful, we've solved Ramon, we've kicked the NSA guys out, so they cannot modify things unless we know about it. And actually, as far as I can see, then we have actually solved the secure device problem. If everything, this is being coded now. So we'll hopefully have a prototype in Cisco Live Berlin in February. So if everything goes okay, you can come there and take a look and see this working in real. It will not be the final code, because that takes time, but at least you will be able to see how things go. How am I doing on time? Okay. So let me talk about open source and standardization, because that's interesting. This is how we see things happening. Autonomic networking is a layer which can make things happen. Things like, for example, BGP or OSPF or something. You should change your passwords on a regular basis. Correct? How many people do change the passwords on a regular basis? Well, less. How many use Cisco 123 as the password? Okay. And so on and so on. Why, if the devices can talk together, why can't the devices just agree on this damn thing? They have a secure channel. They trust each other. They just come up with a random password any day, every day, and just agree on, well, today we'll use this. Tomorrow we'll use something else. Then we have solved that problem, and so on and so on. So if we have the underlying foundation, then we can make this happen. Here again, there's an RFC for this now, so you can take a look. Here's the open source stuff. Open Daylight, which is the SDN controller. We now have something called the SNBI, which is the Secure Network Bootstrapping Infrastructure code, the autonomic code which we created. We have actually put it into the open domain. You can download it and install it and have fun with it on your own boxes. So you could run autonomic networking on a Linux box with Open Daylight, and then hopefully within 3 or 4 months, that code should be able to talk to Cisco boxes running the same code. So we're giving it all away for free, in a way. We will not be charging for all this, because we want to do the cool stuff running on top of autonomic networking, like the security stuff I was talking about. If everyone can talk together in a secure way, then we can have fun with all the cool functionality on top. If you want to read something, tons of drafts, explaining all of this in detail, IETF drafts and actually our actual RFCs, which go into detail about the concepts. They don't give you the code itself, but you have an example code in the source code, in the open source project. So it can help you to proceed. I have not put a slide with the boxes we have today, but we have the ASR 900 series, 903, 901, 903, 920, ASR 1K, ISR 4451, ME. It is all coming very, very quickly. The goal is that this should be running on every Cisco box which we produce in a relatively short time. So the summary, quickly. We are combining a number of technologies. We are beginning to talk together in Cisco to connect together products which actually give you really cool functionality, which can help you to save money, fix problems quicker, and actually implement cool things like this security story which I was talking about. Cost you nothing. Well, okay, you have to buy Cisco stuff, but it will be part of the basic package and will give you these things. So if you like this, then follow what's happening in the IETF. You get all the information, and keep talking to us. More references, more stuff to lead. Here's the alias. If you have ideas, send us an email. We'll talk to you. Okay, thank you.
Thank you very much for your lecture.